Good evening. I'm YU-TUNG KAO, and what me and my team are trying to break is the spread of airborne pathogens. Today, some of the most common diseases, such as influenza, varicella, or tuberculosis, are spread by human-to-human contact through aerosolized bacteria or viral load in air. In addition, globalization and increased traveling are causing concerns for elevating the risk of fast-spreading pathogens involving two pandemics. In fact, the ongoing COVID-19 crisis represents we have a situation that is a very serious problem. While we have observed that many apps and websites are deploying machine learning algorithms to identify potential outbreaks and hotspots, however, these methods rely heavily on an adequate data collecting system, which we have seen that in this COVID-19 pandemic, not all countries have a collecting system that is well established and carried out. So we start to think that if there's a different approach that we can construct a comparably powerful surveillance system, and then which works more effectively by live monitoring and will mitigate the likelihood of failure of such AI algorithms. So we came up with an idea. What if we could detect these pathogens directly through air? So here's our solution, a real-time early alert system. We have designed a device that will sample ambient air and daily at a rate of several times per hour, and in public places such as airports, hospitals, schools, or trains. And then the pathogens in the air will then be tested quantitatively using nanoparticles and immunoglobulin complex as a detection medium. And then we can use electrochemically based techniques such as field effect transistor or plasma to do precision measurement. More importantly, up to nanomolar sensitivity can be achieved. Finally, by measuring these pathogens, and we can establish a real-time database that can then be used to identify high-risk hotspots and further to predict potential outbreaks. In conclusion, our solution is a fast and smart technology that can monitor pathogens in air and creates a real-time early alert system to identify high-risk hotspots and further to predict potential outbreaks. Thank you. Any questions?